Diamond. Diamond is carbon, the exact same element that makes up pencil graphite, charcoal, and the black residue on the bottom of a pan. The difference between a $20,000 stone and the tip of a pencil is not what it's made of. It's how the atoms were arranged under conditions that should not exist anywhere near the Earth's surface. About 100 miles underground, where pressure reaches 725,000 pounds per square inch and temperatures exceed 2200 degrees Fahrenheit, carbon atoms were forced into a specific crystalline structure, each atom bonded to 4 others at the same time. That geometry is the reason diamond is the hardest natural gem on Earth. The architecture is very stable. However, change that geometry by 1 degree of pressure and you get graphite, serving a whole different purpose. Same atoms, but zero value. That same crystalline structure acts like an internal prism. White light enters the stone, splits into its component wavelengths, and bounces off the internal facets before exiting. The shine you see inside a diamond is light trapped inside its geometry because of how complex it is. The modern diamond industry operates on a supply control model established in the late 19th century. Actually, enough diamonds exist in current stockpiles to give every person on Earth a full cup of them. But then it would lose all the value. The scarcity has been engineered for the last 2 centuries. Ruby. For over 1,000 years, the only rubies that mattered came from a single valley in Burma, the Mogok Valley. They didn't collect them just because of their beauty. Warriors embedded rubies directly into their skin before combat. They literally inserted it under the flesh. The logic was that the stone's red was the color of blood made permanent, blood that could not be shed. The British Empire seized the Mogok mines in 1885. You may think it was because of a geopolitical dispute over territory or something like that, but the ruby trade was generating revenue that was directly funding the armed resistance against British expansion. A gemstone triggered a colonial military operation. What makes Mogok rubies distinct is a trace amount of chromium inside the corundum crystal. That chromium absorbs yellow and green light while simultaneously fluorescing under ultraviolet, including the ultraviolet already present in natural sunlight. The result is a stone that appears to generate its own light from within. The Burmese called it pigeon blood because the color was really similar. Gemologists still use that term today as the highest official grading for ruby color, a stone that looks like it is bleeding light. A top-grade Mogok ruby today sells for more per carat than any diamond on Earth. In 2015, a 25-carat Burmese ruby sold at Sotheby's for over $30 million. That is $1.2 million per carat. The valley that caused the war is still producing, still under military-controlled access, and still the single most coveted source of rubies on the planet. Emerald. Cleopatra was an emerald fan. She wore them all the time, but she liked them so much that she owned all the mines. The Egyptian emerald deposits in the Eastern Desert, active since roughly 330 BC, were claimed personally by Cleopatra, and she distributed the stones as political instruments, not jewelry. Foreign rulers, military commanders, and ambassadors received emeralds as a direct expression of her power, her trademark. The stone was currency and political leverage simultaneously. When Spanish conquistadores arrived in South America in the 16th century, they were looking for gold. What they found in what is now Colombia were emeralds so large and so deeply saturated in color that the indigenous Muisca people had been using them as trade currency with civilizations across the entire continent. The Spanish immediately identified them as superior to any emerald known in the Old World. They extracted an estimated 1 million carats in the first century of conquest alone. The science of why Colombian emeralds look different from every other emerald on Earth comes down to their formation environment. Emerald is a variety of beryl, and its color comes from chromium and vanadium impurities inside the gem. But Colombian emeralds form inside black shale through hydrothermal processes, meaning hot mineral-rich water moving through rock, which creates internal cavities filled with liquid. These are called jardines, from the French word for gardens. Under magnification, the interior of an emerald looks like a frozen microscopic landscape. Gemologists use these inclusions to identify geographic origin. A perfectly clean emerald with no inclusions is almost certainly synthetic. Against skin, the green of a fine emerald has a quality that is almost biological, warm, saturated, and deep at the same time, like the color has a temperature. Sapphire.
The sapphire in Princess Diana's engagement ring, now worn by Kate Middleton, is a 12-carat oval from Sri Lanka. When it was selected in 1981, it was considered an unconventional choice. The future Princess of Wales chose her engagement ring the way anyone could. It cost £28,000. Today, it is insured for £300,000. It's the same stone, but the economy has changed a lot. Sapphire is corundum, aluminum oxide, the exact same mineral as ruby. The only difference between them is the trace element present during formation. Ruby's chromium produces red. Sapphire's iron and titanium produce blue. One atom of the different element separates the two most valuable colored stones on Earth. Sapphire comes in every color except red. Pink, yellow, green, orange, purple, white. All of these are sapphires. The orange-pink variety, called Patparacha, is rarer than blue sapphire and commands higher prices per carat. The name is Sinhalese word and it's related to a type of flower. The most consequential use of sapphire today has nothing to do with jewelry. Synthetic sapphire, corundum, grown in a controlled laboratory environment, is used as the cover glass for high-end watch faces, as optical windows in military aircraft, and as a substrate for LED manufacturing. The Apple Watch used synthetic sapphire crystal. The same mineral sitting in a royal engagement ring is being manufactured by the ton for defense and industrial applications. It is simultaneously the most romantic stone in the world and the precision industrial material.
Alexandrite. Alexandrite is not one color, it is two. In daylight, it is a deep saturated green. Under incandescent light, the same stone, uncut, unmoved, turns into a deep red, a complete chromatic reversal. No other natural mineral on Earth does this. The mechanism is not magic and not an optical illusion. The stone absorbs light across two very specific wavelength ranges simultaneously. In sunlight, which is rich in blue and green wavelengths, the green absorption wins. Under candlelight or a tungsten bulb, which is dominated by red and yellow wavelength, the red absorption takes over. The human eye is the instrument being calibrated. The stone is simply responding to what is being fed into it. Alexandrite was discovered in the Ural Mountains of Russia in 1830 on the birthday of Tsar Alexander II. The timing and the colors, which matched the imperial Russian military colors of red and green, made it the immediate national stone of the Russian Empire. The original Ural deposits were exhausted within decades. Today, the finest specimens come from Brazil and Sri Lanka, but original Russian Alexandrite with strong color change is among the rarest colored stones in existence. A high-quality Alexandrite with strong color change in both directions sells for more per carat than ruby or emerald. Most people have never seen one in person. Most jewelers have never handled one. Black opal. The Roman senator Nonius owns a single opal the size of a hazelnut. Mark Antony wanted it, and Nonius refused to sell. Mark Antony, one of the most powerful men in the ancient world, exiled him from Rome, and Nonius fled the empire carrying only the stone. He chose exile over giving his opal. Pliny the Elder wrote that the stone contained the fire of the carbuncle, the purple of the amethyst, and the sea green of the emerald, all shining together in an incredible union. What Pliny was describing, without the vocabulary to explain it, was diffraction. Black opal is composed of microscopic spheres of silica stacked in a regular grid pattern. When light passes through that grid, it diffracts, meaning it bends and separates into spectral colors that shift depending on the viewing angle. The black body tone of the base material, unique to Lightning Ridge in New South Wales, Australia, creates a dark background that makes those spectral colors explode with a saturation that lighter opals physically cannot achieve. In hand, a fine black opal is a little bit disorienting. The surface appears flat and dark until the angle changes, and then the interior shines. Reds, greens, blues, and violets appear from inside the stone simultaneously, from all angles. It looks like artificial glass. No two black opals produce the same pattern. Each one is structurally unique. Lightning Ridge produces almost all of the world's black opal. The entire global supply comes from a single mining town in the Australian outback with a permanent population of roughly 2,000 people. Tanzanite. Tanzanite was unknown to the world before 1967. A Maasai tribesman found blue-purple crystals on the ground near the base of Mount Kilimanjaro after a lightning strike heated the soil and revealed the stones. A local prospector identified them, brought them to Tiffany & Co., and Tiffany launched a global marketing campaign naming the stone after its country of origin, Tanzania. In 3 years, Tanzanite went from an unknown mineral to one of the most commercially sold gemstones on the planet. The stone is a variety of zoisite, and its violet-blue color comes from vanadium. What makes Tanzanite structurally unusual is that it is trichroic, meaning it shows 3 different colors depending on the axis from which it is viewed: blue, violet, and burgundy, all in the same uncut crystal. Cutters have to orient the stone precisely to maximize the blue-violet combination that the market values most. Here is the economic reality. Tanzanite exists in one location on Earth, a single mining zone covering approximately 8 square kilometers in northern Tanzania. No other deposit has ever been found anywhere else in the world. Geologists estimate the supply will be commercially exhausted within 20 to 30 years. There will be no new Tanzanite after that. What exists in the ground right now is the entire remaining supply of this mineral in the known universe. Tiffany still controls a significant portion of the market. The stone that was found by accident after a lightning strike is now a regulated, internationally traded commodity with a known expiration date. Painite. In 1951, a British mineralogist named Arthur Payne brought an unusual red crystal from Burma to the Natural History Museum in London. The museum's scientists analyzed it and confirmed it was a mineral entirely unknown to science. It was named Painite after its discoverer. For the next 50 years, only 2 specimens existed in the world. The entire known global supply of this mineral fit inside a single display case. By 2004, the total number of Painite crystals ever found had reached 25. The Guinness Book of World Records listed it as the rarest mineral on Earth. A small mining operation in Myanmar subsequently uncovered a secondary deposit, and the count eventually reached into the hundreds, but MEM-quality facetable Painite remains extraordinarily scarce. The majority of what exists is opaque or fractured. Transparent crystals suitable for cutting can be counted individually. The chemistry of Painite is unusual enough that its discovery forced a revision of mineralogical classification systems. It contains boron, zirconium, calcium, aluminum, and oxygen in a combination that had never been documented. The conditions required to produce that specific combination are so improbable that geologists still cannot fully explain why even the deposits that exist manage to form. A faceted Painite of even 1 or 2 carats is not something that appears at auction regularly. When it does, there is no established market price. The stone is sold for whatever the buyer is willing to pay for something that almost does not exist.